Hey guys, it's Rich from the HYTOPIA team, and today we're going to get started building a first-person shooter. So first thing first, let's create a new project and we'll call this FPS tutorial. And dev.hytopia.com tells us how to get set up. So first we'll install bun, and then we'll install HYTOPIA and initialize a new project. Sweet. And now we'll run this final command just to test everything's working. And so if we open up play.hytopia.com, now HYTOPIA is fundamentally two-player. And so if we open up another tab, we'll see that it actually works straight out the box. So the next thing we really want to do to make this a first-person shooter is add some guns. Now, if we go into node modules and check the HYTOPIA package, we'll see a folder specifically called examples. And one of the examples in this folder is a zombies first-person shooter game. Now, this game already has some nice features and assets to work with, but we want to see projectiles when we shoot the bullets. And so within the assets folder, we can see several 3D models available to us. And so we can take these and replace all the assets in our items folder. And while we're at it, we can clean up a few other things in these folders as well. We can also empty this projectiles folder and delete the structures folder as well. And if we pop back into the examples, we can also get the soldier model that we use to carry the guns and run around and stuff. And that's useful because he's already got gun-based animations embedded within the model. And so if we go to index.ts, this is where our core code is. If we strip out some comments and some Easter egg code, we're left with very few lines. And if we update the model from player to soldier player, voila, we've now got soldiers. And so next up, we want to make the player model more customizable and also introduce the concept of using guns. So first we'll create a classes folder to handle some of this logic. And the first thing we'll add is the game player entity class, which extends the player entity from HYTOPIA. So the first thing we're going to add are some parameters that will make sense for our player, like health, and whether the player is down or not, and even the sounds that the player will make when they get damaged. We'll also have a getter for our player controller, which defines the key bindings as our player moves around. And finally, we'll add and comment out a placeholder for our gun entity. Now, just like when we defined our player entity in the index.ts, we want to move that logic to our game player entity. And we also want to set the auto cancel mouse left click to false, so that when we're auto firing, it doesn't stop. Then we can set up some basic player animations, set the player camera mode to first person, and we can also set up the player's base health as 20 and also define the damage audio as well. And we can grab that damage audio directly from our zombies example. But why don't we go ahead and copy all of these, since it looks like we might use some of them later. And so we can put them all in our SFX folder for ease of access. Next, let's override the spawn logic. Now we want to be able to define where we spawn this player, so we have to be able to overwrite the position. But the key thing we're missing is we want to be able to give this player a gun. So let's actually make a gun entity. Now this is going to act as the basis for all of our other weapon entities, so let's make sure it's sufficiently customizable. First, we're going to create gun entity options by extending entity options, so we can introduce things like bullet speed, damage, ammo, you name it. And then within gun entity that extends entity, we'll get all of these variables set up and initialized within our constructor. And when spawning this, there's three things that we want to define: the unique options for the gun, the player model that it actually belongs to, and the node within the player model that it's actually attaching to, for example, the hand. And we can create a simple function to define which hand it is based on the option. And the final thing we need to do for now is make sure we can spawn the gun entity. Great, now before we can actually test this, we need to remember that the gun entity is just the base model. We need to first implement the pistol entity, then we can equip that in our game player entity model, and then we can replace our current player model with our new game player entity. So let's create and equip our first actual weapon, the pistol. And so we create a new class called pistol entity, which extends the gun entity. And all we're doing is providing different values for the various parameters it accepts. Now that we have the pistol, let's equip it to the character. So let's uncomment the gun parameter and import the gun entity. Next, we'll add some generic logic to just remove any pre-existing guns and add a new gun. And then we can call this function and provide the pistol entity when we spawn the player. Great, now if we go back to index.ts, we can replace this function spawning the new player entity with the game player entity model. Now, moment of truth, let's check if this worked. Now we can't see anything here, but if I press / and zoom around, we can actually see that our player model has spawned with a gun. But the problem is our first person camera is actually stuck inside the player. So let's fix that. So firstly, when we go into first person mode, we want to hide some of the model nodes. And let's do a couple more things. We want the character to actually hold the gun like he wants to shoot it. And so we'll go back into our gun entity and we'll add some extra animations that actually get passed in from the pistol entity. And because the player is always carrying a gun in this game, we'll just set that up in the constructor. Great, now it's looking better. We can see our players have guns, but it's still a bit low. So let's raise the camera a bit. And we can do this by applying a simple offset to the y-axis. That is looking so much better. Great. Next, we want to add a shooting mechanic whenever a player hits the mouse left click. But in order to do that, we need to tap into the player controller's onTick with player input event. And so onTick with player input will call our function and we'll define that down below. And so if there's a gun, when the player hits left click, we want it to shoot. And if the player hits R, we want it to reload. Now we just need to set up these functions in our gun entity. So if we go back to our gun entity, you should only be able to fire a gun if it's owned and equipped by a player. And then depending on the spray count, which is the number of bullets that get fired at once, For a shotgun, that might be several bullets, but for a pistol, that would be a single bullet. For each bullet, we want to get the origin and the direction of the bullet. And here we have a helper function that lets us do that. And the more bullets that get fired at once, the more it affects the spread and the accuracy of the bullets. And then each of those bullets is fired with the shoot bullet function. Now, the shoot bullet function is where most of the projectile logic lives. When somebody fires a gun, we actually want to spawn a new bullet entity. And for this, we've just picked up the bullet projectile from the HYTOPIA SDK payload example. But because bullets move fast, we don't want it to fly through a player without being registered, so we have to enable CCD, which is continuous collision detection. Now, if the bullet collides with another player entity which is not the parent, we want it to actually incur damage, i.e. reduce the base health. And after it collides with another player, we want it to despawn. Similarly, if it collides with a block in the world that isn't water, then we want it to also despawn. Thereafter, we'll spawn the bullet and apply some velocity in the direction it's firing. And worst case scenario, if you can't hit a thing, we'll despawn the bullet after 2 seconds. Now, the final bit of logic is just some polish. It's some animation and sound on shoot, and we've actually just nabbed that directly from the HYTOPIA SDK docs, the zombie FPS example. And just to finish off implementing that muzzle flash logic, we'll spawn the muzzle flash entity when the gun is actually spawned with a 0 opacity, and then we'll add a public abstract to get the position and rotation of the muzzle entity flash, but we'll implement that directly in the pistol entity. Now, we'll also add a shoot override to validate that the bullet can be fired before actually shooting, but also to add in an animation on shoot and to prevent autofire. And if we return to our gun entity, we can add the shoot validation to prevent ourselves from firing bullets more frequently than we're meant to, and also some reload logic so that we can't fire more bullets than we actually have in our clip. Now let's run that and check what's happened. Hey, that's working. Great. Okay. The great thing now with the way things have been built, we can actually extend the number of guns available to us quite instantly. And so if we go back to our gun folder, we can quickly add all these other guns just by defining the set of parameters that are necessary, the override function for shooting, and the get muzzle flash rotation and position. And that makes it really easy to extend the number of guns available. And the only thing you really need is a different model for each of them. But next, let's make it so we can pick up different guns. And to do that, we'll quickly implement 2 classes. We'll make an interactable entity class just for generalizing a way for us to interact with specific types of entities. And we'll make a simple floating weapons entity class. Now, to run over the high level details, firstly, we want to be able to provide the position, the model, the weapon type, and any overriding options potentially for that particular weapon. Next, we'll extend the interactable entity to create the class, and we'll also make variables to handle the different type of weapons. And because underlying this is just another entity, we'll pass into the constructor the name, the model scale, and the collider options. Now, we want this model to hover down slowly, so we'll set the gravity scale to 0.1, and we want it to rotate on the y-axis, so we've enabled rotations on that axis alone, and we've also added some angular velocity. And finally, we've set up the collision group so that it will collide specifically with blocks. And then it gets the weapon type directly from the options provided. Then we'll add a preliminary spawn override because we're going to add some UI stuff later on. And then finally, we'll add some interact logic, which will allow players to actually pick up the guns. And there's a little bit of logic in the middle to make you drop the weapon you previously had equipped. But to make that work, we'll add a get equipped gun function to the game player entity. But we still need the player to trigger the interact logic within the weapon itself. So within our game player entity's on tick event, if you press E, it would trigger a raycast function, and based on the player's position and the camera's facing direction, it would fire a raycast, and if it hits an entity that's an interactable entity, it will trigger the interact function. Now, to test this, in our index.ts, we've added some logic to spawn a random floating weapon entity every 1 second. And that just takes a random weapon from an array and spawns it in a random position within the world. Great, so let's test to see if that works. And as we can see, that's working fine. A random weapon is spawning every second. And if we go to a weapon and press E, we can pick it up and change the weapon that we're holding. Now's a good time to add in some UI so that we can see a player's health, some crosshairs, the equipped weapon, and even the various floating weapon types. So first, within the game player entities constructor, we should load the player UI. And within our assets UI folder, we should create an index.html file. Now, this is straightforward HTML, so first let's add some fonts. And first, within our UI, we'll add a simple crosshair, but we'll also add the CSS styling. And with a quick check, we can see the crosshair's been added. We can also add some HTML to capture the equipped weapon and the health bar. And once again, we'll make sure to add in the relevant styling. Now, we can see that's working, but we need to make sure we get the image from the zombie FPS example. And we also need to get the information to update when we fire bullets and change weapons. So we add this logic so that whenever the server sends data to the UI, depending on the data type, different things will happen. And we use query selectors to manipulate the document directly. Next, let's add the server logic to send the right data to the UI. And so back in our gun entity, let's begin by adding these 3 functions. We need a UI function for updating the ammo, weapon, and for sending reloads. And when that weapon is spawned with a parent, it should update the player's weapon and ammo. Now we also want the ammo to update whenever there's a reload or a bullet fired. And whenever there's a reload, you want it to send a reload event to the UI. And before we test, we'll quickly add the images for the weapons to our assets folder. So let's check to see if that worked. That's great. Now we can see that reloading, shooting weapons, and changing weapons is all working perfectly fine. But players still don't seem to be taking damage. Let's fix that. Now on bullet collision, take damage is triggered within the game player entity, but that doesn't exist yet, so let's add that function. Now within our game player entity, we add a take damage function which reduces their health on hit, and it also checks to see if the player's been killed. And we'll also add a UI event to update the player's current health. We'll also make sure that the player's health is updated on spawn. And if we test this, now we can see that the player's health is decreasing as expected. And when the player's health hits 0, then the player is killed. Now let's also add some UI to our floating weapon entities. And so we'll create a new scene UI when the floating weapon entity actually spawns. And so we'll provide it with some information like the number of stars, the weapon type, and the ammo. But because it's an in-scene UI, we have to also set the offset and the view distance. And then we'll load the scene UI with the weapon info template ID into the game. And if we go back to our index.html, we can add a template for our scene UI. And then within our script, we can make sure to load the right information for each weapon. That's working, so let's add some basic CSS styling. And so if we refresh, that's looking a lot better. So now that we can fire, spawn, and equip weapons and also kill players, we've got the very basics required for a first-person shooter. The final thing to do is to build a map, which we can quickly do at build.hytopia.com. And there's loads of tools and ways to do this really easily, whether it's block by block, or generating an entire terrain in one go. And you can also add a variety of assets really easily. And I've gone ahead and made a map already, so I'll quickly replace my JSON file. And so now my new map is loaded and my weapons are spawning. Now to finish this off, let's add some actual game logic and a leaderboard and stuff like that. Now we need to implement our core game logic, which will include the game setup, players joining and leaving, and then the cleanup at the end of a game. So to do this, we'll add game manager.ts. First, we just added some basic parameters for like weapon types, spawn intervals, leaderboards, etc. And then also a basic constructor. Now we can add our first bit of core logic for setting up the game. And when we set up the game, we define the world, we set some music up, and we also apply some invisible walls to act as boundaries for the player. And we quickly define these walls in the game config file. And once these walls and their collider groups are defined, we add them to the world. It's worth noting these walls are defined by taking the midway point and then using half extents to extend it out. And finally, we have a start countdown function that we can define below. This is the first function in a stream of functions and is checking have we met the conditions to start the game. This function will set up our start countdown parameter, and if we have enough players, it will decrement it by 1 each second. And once we hit 0, it will trigger the start game function. And the start game function sets up the weapon spawning, the leaderboard, and also sends an update event to the UI so it knows to start the game. And then similar to before, our start weapon spawn system spawns random weapons around the map every few seconds. Now most servers won't start with 2 players, so what we can also do is trigger a countdown on player spawn. And that's all we're doing here, as well as setting up the random spawn location, updating the leaderboard, and attaching the camera. And when updating the leaderboard, we just send the top 10 scores to the UI. Now let's go to index.ts and call these functions. And so we'd want to set up the game straight away, and we'd want to replace the logic when a player joins the world. And if we quickly test this, when we only have 1 player, nothing's happening. But if we add a second player, the timer begins and the game starts. Brilliant. Now let's quickly go back and add the UI components for the game start and for the leaderboard. And so first we add the HTML for both. We initialize our timer interval, and then if the data type is start or update leaderboard, then we update things accordingly. And then we add all the CSS for the timer and for all the different aspects of the leaderboard. And we quickly got that working. And obviously if we wanted to make that better, we could have moved the date now function to be a server-side parameter. Let's do a couple more things so we can make the leaderboard visible as well. Now we set up the leaderboard to be hidden by default, but if we go to the game player entities on tick with player input function, then we can use Q to toggle that on and off. And when players die, nothing really happens at the moment, so we should handle respawns and increment the leaderboard. And so if a player's been taken down, we update the animations and the health, etc. for if the player's gone down or not. And after a few seconds, we respawn that player at a random position high up in the air, and they float down like a dove. And we can do that by temporarily setting the gravity scale to 0.1. Next, we can increment the leaderboard in the game manager. So we increment the leaderboard every time a player gets a kill, and then we update all the player UIs. And then finally, with each kill, we want to make sure there's an announcement. And so in our game manager, we can have a bit of code that will send that update to the UI. And then back to our UI, we can add some announcement HTML. And if the data type is set announcement, we can show that for a few seconds. Let's unnest the leaderboard and set announcement logic, because that will not be triggered otherwise. And then finally, we can add some fancy styling to make this thing pop. And so once again, let's get this tested. And so if we kill a player, we get a fancy announcement. And if we press Q, we see a leaderboard. Great. Now finally, let's end and restart the game once a player hits 10 kills. And so if we go back to our game manager, so first we'll add an end game function, which will announce the winner, clear the leaderboard, check if we can start a new game again, and also stop the weapon spawning in the meantime. And so we add one function to stop our weapon spawning and another function to check and see if we have enough players before starting a new game. And then whenever the leaderboard is updated and the top player has more than 10 kills, we want to end the game. Now we've handled setting up the game, we've handled when players join, we've also handled ending the game, but we also need to handle the condition when players leave the game, because that could also trigger the game ending. And so first, let's replace this with a new function that we're adding to our game manager called remove player. And upon removing a player and the relevant entities, if we don't have enough players still in the game, we end the game. Otherwise, we actually run a check just to make sure that if the game isn't running already, we should start a new game. And now that we finally added all of our game logic, let's do one last check to make sure everything runs well. So our first person shooter starts appropriately, announcements are coming up, and we also have a leaderboard that shows as well. And then if we speedrun our way to 10 kills, and then for our final kill, it says that I've won in the chat, and then it starts the game again. Perfect. And there you have it. In a matter of minutes, we've built an entire first-person shooter from end to end. Now, if you like this video, make sure to like, share, and subscribe. Please do also comment down below if you have other things that you would love to see us do. But thanks for watching. Cheers.